This question asks us which of the following is not true for an ideal op-amp. We know that our op-amp is going to look like the following. It's a little triangle, and we know that we have input, and this powers our op-amp. So we have VCC, and then we also have this input, which is minus V, and we could call this EE. We also have two inputs into our op-amp, and then we have an output where our voltage or current is going to get amplified. And then somewhere we have some negative feedback, but we're not going to draw that just yet. So for this first one, we have the current into the plus and minus inputs is 0. Is this true or false? Well, we know that current flowing into our op-amp is non-existent. So current does not flow into our op-amp. It flows around it when we have other parts of our circuit, but it does not flow into it. So the currents flowing into the positive and negative inputs is 0. This is true. Next, we have the voltage between the plus and minus inputs is 0. This is true because we only have voltage that is going in here, and they are we don't have any voltage in between them. So there is no voltage inside of here, and so that means that this is true. Next, we have the output voltage will change just as fast as the input voltage change. Now, for a non-ideal op-amp, this is not true. But for an ideal op-amp, which is asking us for us, this is true. Because we have the voltage here, the same here, for an ideal op-amp. In part D, the output voltage only changes slightly as the load resistance changes. If we look at the notes linked below the like button, page 8, signal losses due to Ri and R naught are what we need to focus on. We're going to be looking at this voltage, this node divider, this voltage divider. So to reduce our signal loss, our Ri has to be a lot greater than our R source. But right here it says the output voltage only changes slightly as our load resistor changes. Well, if our load resistor is changing, this is going to significantly change our output voltage. So this is not true. The output voltage does not just change when our load resistance changes. It can change for other factors as well. So that is the answer for this problem.